In this video, I am going to present about different types of governing. Let's start one by one. First one, throttle governing. In the governing is generally using for steam turbines. In throttle governing, the pressure of steam is reduced at the turbine entry, thereby decreasing the availability of energy. In this method, steam is allowed to pass through the restricted passage, thereby reducing its pressure across the governing valve. The flow rate is controlled using a partially open steam control valve. The reduction in pressure leads to a throttling process in which the enthalpy of steam remains constant. The low initial cost and simple mechanism makes throttle governing the most apt method for small steam turbines. The valve is actuated by using a centrifugal governor which consists of flying ball attached to the arm of the sleeve. This is a type of governing system which is used in the steam turbine control unit. The fly ball, while rotating the shaft, the fly ball is going towards outward when the turbine will rotate exceeding speed. In the turbine exceeded speed related to the high pressure steam generation. Due to the high pressurized steam will generate a high torque on the rotating shaft. Due to the reason the rotating shaft speed will be increased because of the high RPM leads to outward movement of the fly ball towards the outward direction from the rotating shaft. So while going to outward direction, the fly ball is pulling the sleeve section. In the sleeve is connected with the fulcrum and the lever to the steam entrance into the turbine. So while sleeve is moving upward direction, automatically that lever will stop the steam flow through the stopper or valve in order to control the steam supply to the turbine. So automatically the turbine rotor speed will be reduced and controlled according to the requirement speed, and further the steam exit through the exhaust port. In the turbine, rotary shaft is connected with bevel gears at the end of the shaft. This bevel gear connected with another one bevel gear to control the governing mechanism shaft. So in generally that both shaft will be in that similar speed. In the rotary shaft of turbine will be rotating or exceeding that required RPM. Automatically the fly ball will going outward direction to control the steam flow by reducing that steam into the steam turbine, as well as if there will be some reduction of speed of the rotary shaft also leads to the inward direction of the fly ball, which means where the steam supply will be increased by opening the entrance of the nozzle, and then the steam excess amount of steam enter into the turbine to maintain the constant speed of the turbine rotary shaft. This is the way the throttling governing system is working. Then throttling governing, a geared mechanism connected the turbine shaft to the rotating shaft on which the sleeve reciprocates axially. With a reduction in the load, the turbine shaft speed increases and brings about the movement of the flying balls. away from the sleeve axis. This results in an axial movement of the sleeve followed by the reactive activated of a lever which in turn actuates the main stop valve to a partially open position to control the flow rate. Then nozzle governing system. The flow rate of steam is regulated by opening and shutting of set of nozzles rather than regulating its pressure. In this method, groups of 2, 3 or more nozzles from a set and each set is controlled by a separate valve. The actuation of individual valve closes the corresponding set of nozzle, thereby controlling the flow rate. In actual turbine, nozzle governing is applied only to the first stage, whereas the subsequent stages remain unaffected since no regulation to the pressure is applied. Figure 2 shows the mechanism of nozzle governing applied to steam turbine. As shown in figure, the three sets of nozzles are controlled by means of three separate valves. This is the nozzle governing system schematic diagram. Here they have set up three nozzles: first nozzle set, second nozzle set, third nozzle set, and then there will be some valve and steam in and outlet system where we can supply the steam through the nozzle from the adjustment of valve and steam in system. After that, the steam allowed into the turbines as per required quantity. Thanks for watching. We shall discuss further in that next part. Within this, I will stop.